Hi everyone, I'm Jules Mary on behalf of GenScript, and today we're interviewing iGEM Raters. So, iGEM Raters, will you please tell us more about yourselves and your team and your project?
I'm Lauren. I'm the president of iGEM Raiders. I'm a senior now, and my major is biochemistry.
Hi, I'm Manini. I'm the vice president of the iGEM Raiders, and I'm a sophomore majoring in microbiome at Texas Tech.
Hi, I'm Paula Garcia. I'm a incoming junior at Texas Tech, and my major is biochem. And I'm the wet lab manager and also the website developer for the team this year.
Hi, my name is Olivia Hernandez. I am an upcoming junior. My major is biochemistry, and I am the team's treasurer.
Hello, my name is Olivia Hernandez. I'm incoming for sophomore. I'm an animal science major, and I'm the public relationships coordinator.
So just a little bit about our team. We're a team of 7 undergraduate students at Texas Tech University in Lubbock, Texas. And we're working on the chytridiomycosis pandemic, which is a disease that affects amphibians. And it's caused by this fungus called BD. I can't say the full name because I just can't pronounce it. But it's led to the extinction of many different amphibian species, both with like frogs, salamanders, things like that. So we are working on developing a biosensor that can detect the presence of the BD spores on the frog in the field. And we decided to do a biosensor because we talked to a lot of field ecologists who work on sampling and population genetics and things like that. And they said a big problem that they face is not being able to detect the presence of the fungus in the field. They have to take samples, take it back to their lab, perform qPCR, things like that. So it's not as efficient as if they had some method to detect it in the field. So yeah, that's what we're working on right now.
Awesome. And can you tell us more about the development of the biosensor? So how are you engineering it to come to life?
Yeah, so we don't have all of the project details figured out yet because we're still in the brainstorming phase. But right now we are thinking of making a transcription factor-based biosensor. So we're using tryptophan as our ligand because BD secretes it as like a corn sensing mechanism to control its own growth. So using tryptophan, it'll activate our transcription factor and then activate the biosensor, which we're using GFP as our output.
And with the development of the biosensor, since it detects this infection, what kind of environmental impact or ecosystem domino effect could it have once developed and once the diagnosis of this infection could become more accessible and readily available?
Well, obviously our hope is that this is like a mitigation strategy to mitigate the disease. So with the disease ecologists being able to detect the presence of spores in the field, they could better be able to isolate the frogs, because whenever you sample a frog and take the sample back to the lab, you don't know exactly which frog it came from. You'd have to take the frog back to the lab itself, and it's a lot of just like unnecessary interactions with the ecosystem, I guess. So being able to swab the frog, identify like presence in a couple of minutes, and then like a lot of ecologists also said that being able to detect the presence of spores in the field would also be able to help with studying virulence, because different frog species have different susceptibilities. So being able to isolate which frog species are susceptible to the disease and how the disease affects different individual frogs would better help with treatment.
And has your team thought about what an industrial evolution of the project might look like? So you mentioned that you've spoken to a lot of professors, and this is a lot of the feedback that they've gotten, that it's not so easy to diagnose because of all the steps involved. So has your team thought about what a larger scale production of the test might look like?
We have thought about, well, I spoke to a couple of conservationists, and of course, like with synbio being like a really new emerging like field of science still, having been introduced like about 20 years ago and stuff, and like now very widely used. There's still people who are on the fence, obviously, as to how ethical like just using and implementing synbio into the environment is like. So with human practices, we hope to like educate people more of like different age ranges as well, hopefully, and have them like, you know, reconsider maybe what like our project is like, and just in general like bio augmentation and stuff like consists of. And yes, there are like a lot of safety precautions and ethical issues that come with it, but we hope that like we have enough lab testing and stuff in the future, which is way after iGEM, to possibly like disperse our work into other labs and stuff and make it like a very common thing, hopefully, maybe even standardized in the future.
And can you tell us more about the unique aspects of your human practices aspect for your project?
I think one unique aspect that we've considered for our like human practices would be that most teams focus on like specific age ranges when they want to educate people and they do coloring books and stuff. One of the conservationists that I spoke to is part of like the IUCN and stuff when it comes to like, and also the CCAP, I think is what it's called. And there's a lot of conservation talks and like seminars happening later on this year as well. So we hope to like go to those and be able to attend, whether in person or virtually, and learn more as to like what their strategies for talking to people that who are older as well, and not just kids, and make this like a all ages type of talk, or for our structure of our human practices, because we don't really know specifically how we're going to do it yet. We just know that we want to incorporate all ages into our human practices just to better, because most of the people that make the decisions when it comes to bioaugmentation and synbio implications into the field and stuff, like political aspect, like media aspect of it, are older people as well. So their opinions matter way more. And it also just like, they just matter in general, like since they're the ones making the decisions today as well. So we hope to like sort of influence them, or maybe like change their minds about like this topic.
Mm-hmm. And
go ahead.
sorry. Okay. And like just like another reason why we wanted to do very like a different range, or like a big range, but it's because some with like expertise that, you know, they're a bit much older, more experienced, we want to be able to communicate with them efficiently, and that needs like a higher degree of knowledge compared to an elementary student that's really interested in biology and stuff. So that's kind of another reason why. Mm-hmm.
Yeah, and a big part of our project is accessibility, because obviously our bacteria-based biosensor is not going to be as accurate as qPCR or other like gold standard mechanisms of detecting the presence of spores. So our biosensor is primarily targeting areas, areas where a lot of these like expensive quality equipment are not that accessible. For example, one of our conservationists that we talked to is going to perform field work in Ecuador, and he was talking about how he has to collect all of his equipment now and then take it to Ecuador, because ordering stuff from there, it would take like months on months to receive them. So making sure our biosensor is accessible and easy to use and affordable is a really big deal to us. And that's why our human practices are probably going to comprise of like getting kids out to the pond, using our biosensor to see if we can find zoospores in the pond, while also, like Paula was saying, addressing all kinds of age ranges and talking about synbio.
And is there anything else your team would like our audience to know about your project?
It's just like one thing we've been, it's been a lot of brainstorming. It's been a lot of work. And I just have to say that I'm very thankful for this team. And I'm just very grateful that iGEM was created because I would never have met these amazing students, my friends that I call now. So yeah.
Aww.
Awesome. Well, thank you so much, iGEM Raiders, for meeting with me today. I think your project development is definitely coming along to make a big environmental and perhaps ecological impact as far as the diagnoses for these frogs in the environment. And I think it's great that your team is focusing on accessibility as well, so that this can be made easily available to the public and to researchers. So thank you again.
Thank you so much.
No problem. Thank you so much for meeting with me, and best of luck in the 2021 iGEM Jamboree and our iGEM Jamboree sponsorship competition.
Thank you. Have a great day.
Thank you so
so
much.
much.